How does specific heat influence cooling system design? Imagine trying to cool down a hot cup of coffee with a tiny straw. The amount of heat it can absorb before warming up depends on the material's specific heat. That's exactly what specific heat measures. It tells us how much energy a substance needs to raise its temperature by 1 degree Celsius. In cooling system design, this property is a game changer because it determines how much heat the coolant can carry away. When engineers design cooling systems, they need to figure out how much heat must be removed to keep machines or electronics running smoothly. This is called the heat load. The heat load depends on the mass flow rate of the coolant, the specific heat of that coolant, and the temperature difference between the inlet and outlet. If the coolant has a high specific heat, it can absorb more heat without its temperature rising too much. This means you can use smaller amounts of coolant or smaller pumps to get the same cooling effect. Water is a common example because it has a high specific heat compared to air. That's why water-based cooling systems are so popular in industries and mechanical applications. They transfer heat more efficiently with less volume flow, which cuts down on pump size, energy use, and overall costs. When designing components like heat exchangers or cooling coils, engineers consider the specific heat to optimize the flow paths and surface areas. They want to maximize heat transfer while keeping pressure drops low, so the system runs smoothly. Another important aspect is thermal inertia, which is how quickly a system responds to temperature changes. Coolants with high specific heat can buffer temperature swings, making systems more stable. This is especially important in sensitive electronics or machinery that need steady temperatures to avoid damage or malfunction. In short, specific heat influences how much heat a coolant can absorb, how much flow is needed, and how fast the system reacts to temperature changes. Knowing this property helps engineers design cooling solutions that are efficient, reliable, and cost-effective, tailored perfectly to the thermal needs of different equipment.